Hi, everyone. My name is Lizzie Salita. This is my first time at ReactConf, and it's been an incredible experience so far. I have so many new ideas that I'm excited to take back home, and I'm sure you all feel the same way. I'm excited to share with you all about promoting transparency in government spending with React. So, what is transparency in government spending? Headlines like these may look familiar and have become more common in recent years, thanks in part to a piece of legislation called the Data Act and the website USAspending-gov. More recently in the news, students and employees have been calling into question their employers' contracts with the Immigration and Customs Enforcement Agency, or ICE. These conversations are possible because federal spending data is made available not only to government officials and auditors, but also to journalists, data analysts, and the American public. In fiscal year 2018, the government spent $4.11 trillion. So where did that money go? If you are a US citizen, how were your tax dollars spent? Thanks to USAspending-gov, you can find out. As a side note, fiscal year 2019 totals were announced earlier today, and spending went up to $4.4 trillion in 2019. So who am I, and why am I talking about this? I work remotely from Princeton, New Jersey, where I live with my husband, Michael, and our new kitten, Bobby. And I went to the College of William and Mary, where I studied computer science and also minored in art, so I love to paint and draw in my spare time. I work for Booz Allen Hamilton, which is a consulting firm headquartered just outside of Washington, D.C. I'm a lead technologist for them, which means that I'm primarily a software developer, but also a consultant. For the past 2.5 years, my client has been the United States Department of Treasury. I'm currently the front-end lead for USAspending-gov and a related application called the Data Act Broker. Today, I'd like to share with you some background information on the Data Act, a brief walkthrough of USAspending.gov, and some front-end patterns that we found helpful while developing this application. I'm also going to touch on the impact of this project on government IT projects in general. This mission of financial data transparency is almost as old as our country itself. Thomas Jefferson wanted our country's finances to be an open book, so that every man could comprehend them, investigate abuses, and to consequently control them. Only in recent years have we really had the tools and technologies, like React, to make this vision a reality. A rarity in today's political climate, data transparency has bipartisan support and has been expanded in the past 3 administrations. The Federal Funding, Accountability, and Transparency Act sparked the creation of the legacy USAspending.gov. The Digital Accountability and Transparency Act, or Data Act, required the establishment of government-wide standards for financial data and stipulated that new types of spending data be added to USAspending.gov, which prompted the project that I work on today. The Open Data Act in 2018 expanded federal data transparency efforts to other areas beyond just financial. Our solution is a collaboration between the Bureau of Fiscal Service, my company Booz Allen, another contractor Kearney & Company, and we've also had help from 18F, which is the digital arm of the General Services Administration. It is considered the first large-scale agile government-wide project. And our success has prompted other government projects to adopt the agile methodology. In the spirit of transparency, the code for our API and front-end applications are open source. We accept contributions and pull requests from the public, and we also have a service desk and our Jira boards that are open to the public. We chose React back in 2015 when it had been around for a few years but wasn't completely mainstream yet. We chose it because it was fast, and we knew we needed to render complex data visualizations, and also because it was component-based, and we knew we had repeatable elements we wanted to use throughout the site. Now let's take a look at how a user might interact with USAspending.gov. Let's say I'm inspired by last week's first all-female spacewalk and excited for Alex's talk about building a spaceship coming up after this. So I want to find out more about how much federal money is going into space exploration. From our homepage, I would go to the advanced search page. This is really the bread and butter of our application, and as you can see, there are many different filters that you can apply to the data. Because I'm interested in space exploration, I'll search for NASA as the awarding agency. When I apply this filter, we'll see a table of awards in the results with information about those awards, and it's also broken down by award type, for example, contracts, grants, or loans. I can also view my filters and how they've affected spending over time by comparing different years, quarters, or months. You can also view spending by geography to look at how the spending has been allocated to different states, congressional districts, or counties. Finally, you can view a breakdown of spending by category, and I might be interested in the recipients of these awards. You can click through to a recipient profile page. This one is a child recipient, so clicking on the parent brings me to this company's totals, and I can view how their transactions and the count of new awards has changed over time. There are profile pages for various entities on our site, including agencies and states and federal accounts, which we'll look at later. So I can search for NASA's agency profile page, which will show more information, like the fact that their budget makes up 0.3% of the US budgetary resources for 2019. I can also view a breakdown by different categories like object class, which are consistent across all agencies, for example, personnel compensation. I can also view their federal accounts, which is like a group of bank accounts that are allocated for a specific purpose. On the federal account profile, we can view spending so far, and again view spending over time, and filter by different categories like those object classes. Another feature of our website is the Spending Explorer, and this allows us to explore federal spending from 3 different starting points. I'll choose budget function, which is like a large bucket or category for spending. For example, health or national defense. I can find one for space, science, and technology, and click through to see a breakdown by budget subfunction, which is a smaller category, and click through again. And then we'll be able to see all the federal accounts. And clicking on one of these will also generate a link back to that federal account profile page that we were looking at previously. These tree maps are a great example of why React was a good choice for our application. Each of the boxes is its own component, and we're using D3 to create the calculations and then rendering some custom SVG. Now that we've seen a little bit about how the site works, let's take a look at how it's built. Don't worry about understanding all of this, but the main idea is that we have a schema team that comes up with those government-wide standards for financial data. Those are then enforced by a series of validations in the Data Act Broker, which is the application that agencies log into to upload their spending data on a monthly or quarterly basis. We also ingest data from a variety of sources, for example, getting the latest zip codes from the US Postal Service. The data is kept in our data store, which powers a public-facing API, and USAspending-gov is the primary user of that API. Also leveraging the data is our sister site, the Data Lab. They do more complex data analytics to look at how federal spending affects specific issues, for example, homelessness or colleges and universities. Some front-end patterns that we've found helpful while adding to the site over the past almost 4 years include the container component pattern. So we'll have high-level containers where we connect to Redux, make API calls, and handle data parsing, and then pass that data down to simpler UI components. We're also using Redux. A good example of this is on that advanced search page. We're keeping the store for the staged filters in Redux so that that store can be accessed by both the individual filter containers as well as the submit button container, which uses the filter state to create an API request parameter. We also have directories for data mappings and helpers. Data mapping will convert values like a numeric code into a more human-readable name. And the helpers include our API calls and any sort of reusable logic that we need throughout the application. For example, a common one that we use converts dates to fiscal quarters. We also have API contracts that we use to coordinate with the backend team. This helps us to make sure that we're on the same page when we create a new endpoint or when we are making changes to an existing endpoint. These contracts can serve as a form of API documentation, which you can see here. They also can be run as a mock API if we need to start developing while the endpoint is still in progress. And we can also run tests against the live API to make sure that it's compliant. We went a little bit out of order, but here's our data mapping and helpers files. And finally, our data models are like the glue that connect raw data to our nicely formatted and digestible values for use in visualizations. I'm going to go a little bit more in depth with these because they're really at the core of our mission, taking complex data sets and helping the American public make sense of them. As I alluded to in the previous slides, most of our visualizations have a high-level container that makes an API call. That API response is then parsed using data model objects, which are then stored in Redux or local state and passed down as props. The UI components can then access consistently formatted properties of the object via prototypal inheritance. Our motivation for this pattern came when we noticed that we spent a lot of time trying to trace data points on a page back to their corresponding API fields. Sometimes a designer would come to us and want to change the format of a certain data point. Other times, the API developers would let us know that a field name or response structure was changing. And sometimes someone from service desk or a client would just ask, hey, where's this number coming from? We would have to step through many layers of the component hierarchy and notice that sometimes the same value was sometimes reformatted multiple times in multiple components, thanks to an anti-pattern that Becca called prop drilling yesterday. It was time-consuming and convoluted to get answers and make simple changes. We also noticed that there was a lot of formatting logic cluttering our UI components. As you can imagine on a financial site, we have to do a lot of formatting dollar amounts. And also because it's a government site, there are many entities with both a code and a description or abbreviation. But both of those fields are not always available or required, so we have to format the result based on what's available. This is a very simple example of one place we're using a data model. We're looking at the state profile page for Nevada, which shows the breakdown of spending by award type in the past 12 months. On the right side is the API response, which is a simple array of objects which each have an award type, a dollar amount, and a count of awards. On the left, you'll notice that we've converted that snake case award type into a more human-readable value, abbreviated the amounts with B for billion, M for million, and also added a comma to the counts to make large numbers easier to read. Looking at the data model file, we're creating an object called base award breakdown row and giving it a populate method, which takes one of the objects from the API response as a parameter, and then assigns properties to the object using the data. We're using Boolean logic to cast predictable falsy values if certain fields are unavailable. In some cases, we'll even cast to the string not available for optional fields. Below that, we're defining custom getters, which use our helper functions to format the dollar amount and number. From the container file, a base award breakdown row is created for each object in the array using object.create. The populate method is invoked, and the array of data model objects is stored in state to be passed down to the component via props. From the component, it's very clean and concise to access the data model's properties and custom getter methods. This pattern becomes even more useful for more complex objects and properties that can be shared among multiple models. For this, we have core models. In this case, core location formats addresses, congressional districts, etc. Location data is associated with multiple entities throughout our site. Here, we're using it to format recipient locations. The core model expects data to be in a specific format so that it can be reused even if API fields differ from endpoint to endpoint. So we format the data from the base model and then are adding core location to the prototype chain for base recipient's location property. From the component, we have access to core locations getters because they're in recipient.locations prototype chain. Data models can certainly be overkill in some scenarios, but for us, they've had the benefits of consistency, cleaner component code, and have streamlined making formatting and API changes, because when those types of data requests are made, we know to go right to the data model files. Finally, they've allowed us to reuse data logic by employing prototypal inheritance. Now I'd like to zoom out a little bit. I am a consultant after all, and not all government IT projects are considered a success. The first factor contributing to our success was a strong team. We need talented developers working on these problems for our country. Also, when things get hard, I can fall back on the fact that I'm contributing to this important mission of transparency. Working for the government is a little bit different because you're not motivated by profit and can really focus on making the best experience for your users. Because we're agile, we have a retrospective after each 2-week sprint and are always coming up with ideas to make our code reviews better, have smoother design handoffs, or even restructure our team. And it's been great that our processes have evolved along with the team. We also have a unique relationship with our clients. They're actually a part of our Slack workspace. They can see our pull request, GitHub notifications, can also see when we have to submit a hotfix because we created a bug. They're available to answer questions for us as we are for them, and that helps to build a culture of trust. Also important for the front-end team has been advocating for technical and developer experience improvements. This is not always easy with government clients because they often have pressure from their leadership or audits to ship new features and enhancements. So we've had to learn how to directly communicate the value of a healthy, forward-looking code base and the benefits of improved developer experience to stakeholders who may have a lot of domain knowledge but are not always technical themselves. In the past year, we've upgraded from React 15 to React 16, so we're not the quickest ones to the draw, but I consider it a success that it happened. We've also upgraded to Webpack 4, and that combination allowed us to show significant performance improvements to our clients, which then helps to reinforce that trust. We've also learned to be comfortable with making incremental improvements. For example, with each pull request, part of our code review checklist is to look for opportunities to add hooks, remove deprecated lifecycle methods as we work on new features and enhancements. This project has also had an impact beyond just the site itself. First, as a success story for Agile in government. A similar financial reporting system took about 4 years to develop, and the MVP of the Data Act broker application was developed in about 6 months using Agile. This is because Agile allows for incremental progress. We're able to get more continuous feedback, perform user testing, which helps us to deliver value with every sprint. USAspending-gov also served as a predecessor for recreation.gov, another site that Booz Allen has been involved in, which uses Agile and a modern tech stack, including React and AWS GovCloud. If you're looking to plan your next trip to a national park, this is a great site to check out as well. Because we're open source, other projects have been able to use our components and code as a reference. I know from talking to colleagues at Booz Allen that, for example, the FDA was looking to leverage our glossary component, which is pretty neat. Finally, our data visualizations have been cited as examples as new projects have been starting up of the type of data visualization that they're looking for. As developers, we all stand on the shoulders of giants. So I'd like to thank the entire DataAct team, and specifically the past and current front-end teams. Mike and Kevin taught me much of what I know about React and helped to spearhead some of the patterns I shared with you today. Max and John have embraced our culture of continuous improvement and courageously advocated for technical improvements. If you're interested in finding out more about what the government is doing with open source, code.gov has a list of open source government projects, and they've also created the US Web Design System, which is a pretty complete design system. They even created their own font, which is really cool. And they also have great examples of common React components that are used on government websites. Finally, at USA Spending, we're not perfect and would love to see more pull requests and contributions from developers like you. Thank you.